Hey, I'm Rohan, an incoming freshman at Georgia Tech for CS and Math. A brief rundown before I begin. I created a project and a basic curriculum to see how this would fit in a class setting. With this, I'm fulfilling the standards of empowered learner, innovative creator, and computational thinker. All my code is linked in the description, so let's get started. Today, I'll be covering a computer science concept called recursion. Recursion is a fundamental tool in many pivotal computer science algorithms, but we'll break into recursion with some art, like the pictures you see here. You've probably seen the first, the famous Mandelbrot fractal, and the second is a wide tree fractal, which we're actually going to be making today. So let's start by defining recursion. Recursion is the repeated application of a recursive procedure or definition. Ironically, this definition is recursive, but this basically means a procedure that calls itself. So what do we mean by this? Let's take this extremely simple example. We have a recursive function written in Python which returns itself. It seems almost too easy, right? Well, there are a few minor catches, but let's see what happens when we run this. So here's a visual diagram of what we happen if we call this function with an input of 2. The function will call itself with n-1, but it doesn't stop there. You might have guessed that this will go on infinitely. That's because there is no condition on which the program stops making recursive calls. This scenario, it results in what we call a stack overflow error during runtime. Simply put, because we make infinite calls, we use up more space than the program has been allocated, hence the overflow. Here, I've slightly modified the code with an if-else in the function body. So how did this fix the program? Well, the if statement is what we call a base case. This is when we decide enough is enough and terminate the recursive calls. In this example, I set my base case to when n is equal to 0, in which case we don't make any further recursive calls. So here's the output. We call recursive of 2, and that makes a recursive call with the parameter of 1, which again recursively calls with a parameter of 0. So before we dive into the project, let's recap. Recursion is easy to implement. We define our function and always define a base case. I like to do this first so we know the constraints from the beginning of the program. Then you can add your recursive steps and call the function. It really is that easy. So let's look at what we can do with recursion. So now we'll be implementing recursion to create some fractal art. First up is a Koch curve, a classic example of recursion. Here you can see my base case is a straight line, and my 4 recursive calls just add angles in between these lines. So let's take this program for a spin and see if we can make some cooler art. So let's go ahead and look at this first method, the same one we just talked about. And let's go ahead and run this program at level 2. All right, so this is pretty simple. This is level 2 like we saw on the slides. So now let's up this maybe to level 3. And level 3, you'll see a lot more treading out triangles. Oh, look at that. So now let's go a little bit more, and this will take a lot of runtime. But let's go check out level 5 and look at the level of detail that's in those. All right, so now it's done. And you can see just the amount of detail here is insane. So here's what we're going to do. We have the Koch curve now. And I've gone and created a method right here, the Koch hex, which is basically a hexagon. And you can see here that I've called the Koch curve method 3 times, rotating it. So you could probably already kind of tell what this is going to do, but let's check it out. And I'm going to run this at level 3 just to keep it fast. All right, there's one Koch curve, there's a second one, and there's a third. And you can see here, there's the Koch snowflake. And yeah, this is really cool art. Let me go ahead and run this at level 6. You can just see the amount of detail. I'm going to speed this up as well, but when it's done, you'll see the result. So that was super impressive, making a really elaborate snowflake just with recursion and a few lines of code. Let's look at another type of fractal, the Y fractal. Another more complex fractal, again, is the Y fractal. You can see here the base case is a straight line, and we go out to branch into the Y on the first level. Second level and onwards, you can see that at every branch we go and create another Y. You can see from level 3 to level 4, every leaf, if you will, has now become a branch for another Y. Let's look at this level. Oh, you probably can't see the text here because my face is blocking it, sorry. But this is a level 10 Y fractal tree. And if you look at the method closer, this differs from the Koch curve a bit because the Koch curve only has size and level attributes. Now we have 2 more attributes, angle and scale. So this is a pretty default Y tree and a level 10. So let's go ahead and play with these and try to see what art we can create. And I won't be able to run these because they take a lot of time to run. Again, all the code is linked in the description, so you can go and check it out. So these are more Y fractal variations. You can see here we've played around with a few of the attributes of each one. and you can see how they just differ wildly. You have some square shapes here, triangle shape here, trees. You have some really bizarre looking trees like this one in the middle. It's crazy. You can see how you can make so many different types of art with the same algorithm, just a few tweaks and a few constants in the method. Now, as a CS major, I personally don't have that much creativity. And this, as you can see, my best attempt at drawing a dog. I'm not that great of an artist, but through recursion, I can create art like this by changing some colors, playing it around. So I guess a CS major can be artistic. It's just a matter of applying your skills in the right way. So you might be wondering, why do I need to know this? Well, recursion has a lot of applications. You can see here, here's some searching and sorting algorithms, which is how a lot of things run, like your search engines, your social media apps, everything. And so these are really important. Next, I mean, if you have heard of the Fibonacci sequence is a recursive sequence. It sets the grounds for the golden ratio, which sets a lot of the rules of nature that we see. Finally, there's a lot of mathematical proofs that use induction, which is another recursive method. These are just a few applications of recursion, which dictate a lot of the way we live our lives today. All right, so that's my video. Hope you enjoyed it. And so I guess we just end this. That'd be kind of a lecture, and then we just end it. But with the exercise, like I brought up the Fibonacci sequence, I guess a logical next step would be to create the Fibonacci sequence as a starting step for learning recursion. And then you can have students like take my example code and make their own fractals. Thank you.